So we've got our CTO Jesse. We just had a great conversation with JT. So another like Telos OG, I guess, right? Yeah, and right before we started recording, you and I were chatting a bit. So there's a few things I think we can delve into that'll be very interesting for people. I guess probably most Telos community people know quite a bit about you, but maybe you give a little bit of an overview. And then I'm going to ask you some stuff about native. But yeah, please tell us a bit more about yourself and what you're doing these days and how you're feeling about things.
Sure, yeah, absolutely. So I helped launch Telos probably 5 years ago, 2018, after about 6 months of preparatory work and over 100 different people kind of contribute in the ways that they could contribute. We got Telos launched. Before that, for about 10 years I was doing enterprise software. I learned all about software and engineering and business and how a company goes from 120 people when I started to 5,000 people in 2015 when I left, and through an IPO and all of the things that happen when a company goes through those growth moments. So that was a great experience, and then we launched Telos in 2018. I was at a startup with some friends, and then we, about 2.5 years after that, started building an EVM, and I kind of grabbed a hold of that and started really, trying to get that live and at a high quality, because there was a big opportunity for us, and we have this incredibly fast technology that I'm a big fan of, our WASM-based network, and then the industry was just all about solidity, the level of tools and the maturity of those tools, availability of developers that knew how to build on an EVM coming out of the Ethereum community. Here we are at ETHCC, talking to all those people. It's very evident that it still is a leader, that technology, even if it's not perfect in every way. First mover advantages can be tremendous and they can be sticky. So we added the EVM 2.5 years ago. And that's, I think, around the time that you found us and involved.
Well, when they Sentinel fuzz tested it, and it almost brought down Ethereum.
Yeah, we got to give kudos to Sentinel and Guido for finding that bug. And he found plenty of issues during the audit, but one of them actually wasn't ours, and that was the one that made headlines and was in some way, through the butterfly effect, why we're here today. So,
yes.
And so we deployed the EVM about 2.5 years ago now, and raised some money finally after we launched with no ICO, and worked for 2.5 years just for the token and for the tech, like they say. And so I was able to come on full time into Web3 about 2 years ago then, and been here ever since. A year ago we brought on Alberto, who everybody I'm sure now knows, and he's just an incredible mind, especially in the context of zk.
Yes.
His experience is tremendous, and we've started to grow the team. He's brought on some of his peers from his network who are also just great, and we've all been working together now. Alberto for a year, and Daniele, and then Paulo, and Marco's here now. We've got a pretty solid team that are very capable, and together for the past 3 months. But of course, as we led up to ETHCC, it accelerated, and we put together the live POC demo of SnarkTour.
Yeah, there's some great videos of you talking about that actually. On our Twitter.
It's just been incredibly rewarding being down there, exhausting myself in every way possible, talking to people about what we built, and this conference, compared to like other conferences I've been to, the people here are just really smart, and they're really curious, and so I get to have those kinds of conversations that I love to have.
Right.
To be honest, like at a conference like Consensus, maybe I'm having conversations that are not.
It's more
fun.
businessy,
Yeah. So and then here we are on day 4 of ETHCC, and.
So I think what's interesting with you is, you're a very capable, talented, smart guy. I know you work hard. But you also, we can go from Telos native and deeply talk about in great detail, technical merits and challenges and etc. But we can also go all the way to all the latest cutting edge ZK stuff, right? And because you're kind of involved in everything. So I'd like to maybe go on a little bit of that kind of a journey for this conversation. And like I said, we just spoke with JT and we had a great conversation talking about delegated proof of stake as a base layer. Obviously this WASM-based network. And one of the things I keep talking about with the community is sort of like delegated proof of stake. The current infrastructure that we have is actually quite robust and resilient. It's produced 350, almost 400 million blocks, no downtime for 6+ years. There's a very low entry barrier, right? You don't need 32 ETH or a tremendous amount of money to participate. We're seeing more, let's say, active voting and governance participation from the community, which is wonderful. And of course, with the EVM and with bridges, which as SnarkTour develops and recursive proofs continue to mature, we're going to have trustless bridges. We can now have our token effectively useful even in an L2 context on Ethereum. And so we retain sovereignty, even though we can be hopefully a competitor in the L2 space and so on. So really, and then of course, one of the things I said with JT in the last conversation was at Ethereum, we had these like core values, if you will, particularly in the beginning: low entry barrier, accessibility for all. And then of course we went from proof of work to proof of stake, ostensibly for environmental reasons and low energy requirements, etc. But the reality is the entry barriers are high, it's kind of a whale chain, and the energy footprint is extremely massive when you look at the entire history of Ethereum. Whereas with delegated proof of stake and Telos, all of those core values are actually true and continue to be true, right? And so, yeah, I'm just wondering if you can riff a little bit about delegated proof of stake, and basically this core infrastructure that we have on Telos native, your thoughts, some of the challenges, etc.
Yeah, I mean, and as you said, I've gotten to learn a lot from Alberto and now the rest of the ZK team over the past year and a half. And it's true in all software and in many aspects of life that there's always trade-offs. So on our delegated proof of stake network, we can do thousands of transactions a second. We pushed like 15,000 through the EVM, which arguably is less capacity than if you just purely did it on the WASM network, because there's overhead to EVM execution. And I would say, that's a lot. How do you do that? Well, you put the entire state of the chain in RAM, which lets you go fast, but also results in a constraint in terms of how big it can be. So we've seen some of the other networks running the same software hit those constraints.
Yes.
So there are downsides to everything, but at that point, right now we've been really conservative. So when Telos launched, we launched with a really small available resource pool for RAM, which meant even today we don't have any of those problems, and we have a lot of room to grow. Whereas some other networks, they encouraged some of more spammy activity to get attention, to move their way up the ranks on DApp radar and things, and as a result, they've got huge memory requirements for their nodes. So that's one trade-off we have. One of the things we've kind of gotten to finally realize in terms of an accomplishment with the SnarkTour demo, because the SnarkTour demo was coupled with the game of Battleship, which is the quintessential ZK game. And that whole thing was originally built by RISC-0, and we adapted it to work with our smart contracts and modified it, in a few different ways. The entire stack is built in Rust. So not that I would do it myself, but the front end, the actual web game that you see in the browser, is implemented in a Rust browser framework, which, usually you'd use JavaScript, TypeScript, but this was Rust. And then the privacy layer that actually creates the proofs for the user and runs the RISC-0 VM or the Plonky 2 circuit is all Rust. And then the smart contract, the Battleship logic that's on chain to enforce the game, is also all in Rust. So I think that is kind of like a first of its kind.
Yes.
Rust throughout the whole stack. In fact, we were able to have all those components share the same data structures in one definition, so you don't have to like recreate the data structure on both sides of the API, so to speak. They actually share that, which is, it's a great thing for an engineer to not have to worry about like, oh, you know, when I call this API, this is the response structure,
Yes.
and I'm going to recreate it on my side, but you actually share that same structure. So using Rust for everything has been really cool.
It's very coherent.
Yeah, it's a simple approach that if you know, if you're a developer, you're going to enjoy, have it all in one repo like that. And you get that because it's a WASM network, and anything that can compile to WebAssembly is a candidate for writing smart contracts. Originally, it was all in C++ when the network launched, and so that maybe was a turnoff for people. But now that we took on this project and I started using the Rust WASM compiler that was available to write Rust contracts, I'm like, why didn't I do this sooner? Because it's been nice. And then of course, it's interoperable with all the other things we're doing in Rust. ZK is very Rust focused. So WASM in that case has been great. One of the other really powerful things about WASM is it's fast. That's also part of where we get our speed from, is that, you know, WebAssembly is a good high performance runtime. And
Yes.
so there's a lot of different things. And then, you know, DPoS, right? The delegated proof of stake, the voting. It allows everybody to contribute based on their stake in the network to the consensus of what validators are running the network. We also use the same token and concept for various governance votes, so that
Yes.
everybody has a say in what the network does. As any major, you know, decision is made around governance and the direction of the network, we put it to a vote so that everybody, you know, can debate it, you know. So then you get into that situation where, and again, everything's balanced. Decentralization is a spectrum. So centralization, single, you know, dictator approach towards life and governance and everything in the world, you just do whatever they say, right? And then you go to the opposite end, and everybody has a say, and everybody's participating, and everybody's contributing their thoughts, and then, you know, you can get chaos out of both ends, and somewhere, you know, in the middle is the sweet spot. So that's just it's an interesting thing to see it evolving, and other networks using DPoS, and other networks taking different approaches to it, you know. There's proof of stake with slashing. There's so many different elements to, you know, arriving at consensus on a set of validators.
Yes.
That you know, it's always a challenge, and I don't think anybody's perfected it, but what we have works pretty well, I think, and it's proven itself over 5 years, and
Yeah.
so it's a bit about the native layer.
Yeah, I think that's a really good take. And you know, you talk about WASM and Rust, and sort of like these things are basically native to Telos. And I talked earlier about these sort of Ethereum values and things we aspire to. And obviously, WebAssembly was a big effort. And old buddy of mine, Martin Bexay, was in charge of that for some time. And anyway, and of course, Rust now is very hip and cool in Ethereum and Paradigm with the Reth implementation, etc. But like somehow, you know, Telos is like already kind of there, and it's inherent to the system.
Mm-hmm.
And as you said, later it kind of potentially presents these great benefits as you get into, for example, the ZK side of things, and you know, these like coherent APIs, for example. So kind of like switching gears and maybe getting a little bit more onto the ZK track here. Obviously, we've had a pretty big pivot, and by the way, later we should talk more, because with JT, I agree, we also should look at native a bit more, and he and I were talking about the Rex exchange and just kind of like thinking through some of that. But on the ZK side of things, it seems like, yeah, we've got a bit of traction. We're talking to a lot of different groups, obviously SnarkTour. I'm just wondering, yeah, maybe if you want to riff on how you feel about what we're doing, where we're at, and the kind of general state of the ZK ecosystem. I guess before you do, you're just kind of like, my take on it is always sort of like, you get these like massive projects, and I always say I respect these people. I think they're wonderful. I mean, the researchers are my heroes. And in many cases, they also have very big venture capital, so tremendous amounts of capital, probably lots of different opinions going into maybe strategic and other development. And maybe sometimes that translates into strong assumptions about something, a particular type of prover, for example, or architecture. And then later, obviously the pace and cadence of everything is increasingly accelerating. Suddenly it's like these strong assumptions become invalidated, right? And so I liken it to engineering like a jumbo jet in mid-flight, right? It's hard to do. Whereas Telos is kind of like, we're fast, we're agile, we're researching everything, we're testing everything. We don't necessarily have constraints in terms of what we can do. We can fail real fast, we can fail real cheap, we can be agile. And when these components become mature, we can assemble them like pieces to a puzzle, and suddenly the sum of that is like a performance system. So yeah, I'm just wondering if you can kind of riff on this stuff, and I'd love to hear how you're thinking about what we're doing.
Yeah, I mean, you have a good point that we're not really married to anything, right? What we believe in today, and I think strong belief, closest thing to marriage is, zk. It's a powerful technology, and it's, I think, going to revolutionize the industry of like blockchain. It already is, but also I think it's going to potentially be like the glue to the Web 2 type worlds, because, again, my background in enterprise software, I know how businesses work, how slow they work, how reluctant they are to do things. Possibly those are the reasons they're not here today in Web 3, but I think that with zk, it can provide the trustlessness and the confidence, when done right and properly at scale, that they actually are comfortable to enter. And when they, when one does, they all do. So it's kind of a sudden thing once it happens, and it could be that zk is the catalyst that gets us there. So I'm excited to be here in Web 3, helping lead some of the scaling parts of it, and participate with all the other players that are doing such incredible things on the prover side, the zkEVM side, and everything, so that I'm here when that happens, and we can unlock both mass adoption from like the enterprise and the business, but also from the retail side, where all the users might be doing things with zk, that many of which need to go then on a blockchain because it's a decentralized place, and they don't necessarily have to trust the blockchain, the validators, because it's the zk that actually gives them the security and the trust, and not necessarily this set of validators they may or may not know exactly who they are, right?
Yeah.
So as far as like the zk stuff, it's a game changer. To me, the possibility of having like a succinctly provable chain. So when Alberto came out to where I'm at in California for about a week, a little bit after he joined us, and we spent a week just with a whiteboard and just went for it. And I learned a lot at that point. And one of the things that was really like an aha moment for me was like when he explained and helped me understand what a succinctly provable chain can do. And it's there are some chains that are doing that or trying to do that, but the idea of having a chain that can be not just rolling up to a main chain, but more of a mesh network, a peer-to-peer network of chains that can prove to each other about their state, and also just in general, like a zkEVM rollup, and the fact that you're not relying on the decentralization of 100 or 1,000 nodes all agreeing on something and all having to do the same work. You're relying on one node, a prover, to create a proof, and then you just trust that proof. It kind of just is, it just immediately becomes so much more efficient from that perspective.
Yes.
And it provides not just reasonable confidence in a super majority of nodes, but it provides trustless confidence in the zero knowledge proof.
Sorry, just on the efficiency side, can you drill a bit more into that? Because this is really important, this part.
Yeah, absolutely. So like, while I will fully acknowledge, and it's important to say that generating a proof is highly intensive computation.
Yes.
It requires a lot of computational resources to generate a proof. In fact, to generate proofs of a blockchain execution, like in a zkEVM, to do it efficiently at scale, they actually break up an entire block of transactions into multiple pieces and have multiple provers proving part of the execution of that block. So it's not just like one machine does one proof and then boom, it's many, but they are basically doing like only what is necessary, right? There's not incredible redundancy, right? And in order to build more trust about the validity of a block execution, you don't do that by increasing the number of duplicate efforts, right?
Correct.
So if you look at a network of 1,000 nodes and maybe they're run by 1,000 different people who have 1,000 different machines with access to them, or maybe they're run by 50 different people. It's hard to know that. Like, if 1,000 nodes represents 1,000 independent people,
Yes.
to be colluding or compromised in terms of security. And if you want to add more security, what do? You just need more validator nodes,
Yes.
right? You just need more validator nodes. And then but what are they all doing? Well, they're all doing the same thing.
Yes.
And just have more of them agreeing. And that model is, while it is a huge improvement, and it's, blockchain and Web3, why we're here, over other models where you're just trusting a business who maybe doesn't have good aligned interest with you, and you're trusting the people that work there to not do the wrong thing. It's a big improvement over centralization, but when you start thinking about how you add security and just more duplication of efforts is just not an exciting solution to that. And if you come back to zk, no, it's actually just do exactly the things needed. So
Yes.
you actually remove validators. You don't have validators on a zk EVM or a zk based blockchain protocol. A succinctly provable chain that's not even a layer 2 also doesn't have validators. It has provers, and the same maybe parties operating those nodes can now operate the provers, but they're all taking turns in proving a section of a block or a block.
Yes.
They're all participating, and they're not like all duplicating the efforts.
Yes.
But they're all working together to produce a proof of a block, and the faster you can prove those blocks, the sooner you can reach a finality.
Yes.
Which is what allows people, finality is the point at which you know that your transaction is in the history of the blockchain. So that's where, when I say efficiency, because as I'm sure everybody's heard, our software, hardware co-design, working with Panos and accelerating the proof generation and all that work.
Yeah.
It's not, it's because it takes a lot of compute power to generate a proof.
Yes.
So it's efficient insofar as it's not heavily redundant.
Right.
And it's trustless and more secure.
Yeah, so it's like succinctly provable means that you have this efficiency gain because you can construct blocks quickly and validate them based on proofs. However, and this is like tremendously more efficient, however, and because it reduces redundancy, and what we're actually doing these days is just scaling redundancy, mm-hmm. which maybe not the best approach, even though it is better than, let's say, past centralized systems. But all of that comes at the cost of, you still have to do the proving.
Yeah. And
the proving is compute intensive. So the way to make the entire system, this holistic, net benefit means you have to somehow accelerate the proving. And accelerating the proving means taking a hardware software co-design approach, and ultimately, we believe, probably, even though there's an FPGA interim step, probably an ASIC final step. And so now you have very fast, low cost, efficient proving, in addition to this, in terms of this succinctly provable chains and the efficiency benefits they present. And together, you seem to have like a really great system.
Yeah, absolutely. Yeah. So that's a dream. And
yes.
And the other thing that I think also on that first visit with Alberto, when he helped me really understand the succinctly provable part, it also includes, and this gets somewhat into the deep weeds of technical stuff, but that you, at any point in the chain's history, you just need a proof of its current state. and you're able to actually, you don't need the block history
Correct.
to know what the current state is, which is not necessarily true for all, zkEVMs even.
Yes.
It's a entirely new concept beyond just using zero knowledge to prove execution of an EVM. It's using it to prove state and consensus so that you can have a proof that allows you to start up a node or potentially like run a light client or potentially everybody could run, a node, so to speak, because it's not like this node is just running and chewing up blockchain data at all times. It's an efficiency optimization and a security optimization to get to that. That's really like a North Star goal for like blockchain as a whole, to get to that level and not have sacrificed user experience, cost, etc. Right? So it's like,
well, the meme I use is like that North Star goal to get there is also, I think, the strict requirement that AI on-chain will demand. I mean, if you're an intelligent system, you're going to, like, if you're an AI and you're out there and your purpose is to be on-chain and do smart things so that you sort of like, make money for your client, you're going to demand a fully provable system. I mean, you're going to demand this North Star system that you're describing, right? Because there is no exogenous risk in that system. You know exactly where you stand. And so that's why I say it's kind of like, even though the ZK stuff might look like, oh, there's not much going on, but then suddenly we reach a certain point and there's no unseeing it, right? There's nothing else AI will use on chain than this.
Right. Yeah. Once you like understand these certain things, like, again, before Alberto joined us, ZK was a concept. And then when I understood certain fundamentals, I'm like, first of all, Alberto is very clear on certain things. There are certain sacrifices that he's unwavering on. And once I understood why he's unwavering, like you said, I immediately, no, I wouldn't want to do it any other way either, because it's like, you can't unsee it. Once you understand, you don't want to, you can never go back.
Yes,
right?
Yes. Yeah, okay. No. And I hope this gets across. I mean, we'll edit it, we'll make it look good, but like, I think this particular conversation, is very, very important, because the ZK stuff, first of all, is very hard. It's quite nebulous unless you drill into it, and like, and even to arrive at the end point of this conversation is hard, because there's so many dependencies and you have to understand certain things. And I think you're a very articulate person, so even the way you explain it is sort of rare, right? Because most other talks you listen to, it just gets deep into the technical weeds and you have to know how to interpret that. But the reality is, if you get to that North Star end state that you described, it's like, that's the new gold standard. And that's why everybody right now, all these like tremendous ZK researchers, all this capital, everything is going into innovating in this space, because that's where the brightest minds can kind of, at this time in this space, can sort of agree is the direction we need to go in, right? Because once you get there, nothing will be more efficient, right? Nothing will be more, let's say, transparent insofar as you eliminate some type of unknown risk or ability for a minority set of actors to improperly manipulate the system. But also you get these, like, in addition to low-level performance characteristics, higher level feature sets as well. And all of that combined is like very robust, right? So you're not going to use anything else.
No.
Right?
It feels like, although, just like you said, everybody kind of knows we're trying to get there. Like, not all actors in the ZK, engineering space and industry here are like meeting daily or even at all to say, let's all work towards this. I'll do this part, you do that part, right? But generally speaking, I think most people that understand it do know, like, we're just all trying different approaches to get towards this goal that once we get there, it's going to basically make a lot of the stuff that's been done just obsolete.
Yes.
It was all part of the journey.
Yes.
And how we got there. We wouldn't have gotten there without that, right? We wouldn't have Ethereum without Bitcoin. We wouldn't have, ZK.
We wouldn't have proof of stake without Feathercoin. If you remember Feathercoin, back in one of the first, I think it was the first proof of stake network. I remember in like 2014 or something, somebody tweeted it was like a photo of a Raspberry Pi node with a little solar panel, and it was running Feathercoin. So there's
it was lightweight because it wasn't doing proof of work.
Exactly.
On a Raspberry Pi.
Exactly.
Yeah. Makes sense. So it's all the journey, it's all the building blocks, butterfly effect,
yes.
Just like that Geth bug that we found and how we got here, like all the things that have been done in the industry, we don't know where we're going to end up, but we're starting to feel like we are going in this direction. zk will take us there. You can see just over the last 2 years at these events, just zk going from like, oh, the zk guys are over at that booth over there to it's everywhere, right? Yeah. So it's exciting. It's confirming,
It's hard.
It's hard. Oh, and it's incredibly math intensive.
Yeah.
And so, but again, that's where like the tooling and like all the work that's being done, right? So having zkVMs,
yes.
like RISC-0 and SP1 and now Jolt from A16Z, and all these people are coming in and trying to enable regular developers, not that every developer can write Rust, and that's what most of them are using, right? But
most developers are not using Solidity, by the way.
That's true. There's a lot that are that come into Web3 and they're like, why do I have to learn a new language?
Right. Yes.
So the fact that I am not a math PhD like Daniele and don't have years of cryptographic engineering experience, but I now today can write a zero knowledge program through the zkVM. Write some Rust, implement the logic of Battleship.
Yes. And
now I can get a zk proof without having written a circuit in Plonky 2.
Right.
And the fact that I can do that is significant. Now it's much slower than doing it the hard way in a circuit, but that all changes as the software improves,
yes.
As the hardware improves. Just the fact that I can do that now, knowing how technology works, means that it will just get faster. You can't undo that, and now more and more people have access to the technology, and we're going to see, hopefully, more and more of the use cases that you dream of and talk about as a theoretical possibility. You just see them get built.
Yeah.
And then we get them scalably put on a blockchain with something like SnarkTour, and then you get those blockchains to be trustlessly talking to each other.
Yes. And
you hit this inflection point of, zk all the things, and now everybody can do stuff. They don't have to trust, like you said, a minority of bad actors potentially corrupting a system, and now we're doing, and then we go all the way back to servers getting hacked and you losing your password and all the data in that machine, and all the things, when I joined Web3 in like 2017, everybody's like, I'm going to put medical data on the blockchain.
Right.
Because that hides it. It's like, no, it doesn't hide it, right?
No.
Like all the things people think blockchain's going to do for them with privacy and data.
Right.
It's like, no, it's actually nothing like that. But now we're actually talking about how with zero knowledge,
yes,
you can actually prove facts about your medical data and, not put your medical history on the blockchain, but actually solve the same problem in a different way.
Correct.
And we can start seeing like some of these use cases that are just, they're relevant to everybody.
Everything.
Have nothing to do with, meme coins and, all the stuff that people see as crypto and blockchain today.
Yes.
We can see all that stuff start to happen and work at scale.
Yes.
And then we have,
Yeah. Well, you're obviously an enterprise guy. You have a tremendous background, and you sort of think about these big companies and businesses, and when they have data retention requirements or KYC requirements or some requirement that mandates they collect sensitive data, now it's their problem to not get hacked and lose that data. And then if they do, later they get sued and there's a whole host of like headaches and problems and expenses. And if you're an enterprise, and this is, I think, the core of what I interpret and I believe you're trying to say, with zk and blockchain extending beyond these narrow kind of use cases that we think about today, like trading meme coins and just whatever. But the reality is, if you can leverage the blockchain plus zk to enable a large enterprise to absolve itself of the risk and cost associated with capturing and retaining data in order to satisfy requirements that maybe could be regulatory in nature, and instead they could still satisfy those regulatory requirements by verifying proofs that correspond to data they need to check, without them having to then hold that sensitive data and risk getting hacked and later getting sued. That is a very real, very strong value proposition.
Oh yeah.
Right? And when you're a large enterprise, for example, and you see that, right, you don't unsee it.
No.
Right? Because doing it the old way of collecting the data or having your customers give you PDFs of their sensitive, passports and licenses and everything that go into who the heck knows what kind of storage system where one IT administrator is overseeing, right? That becomes crazy risk that you're irresponsible as an executive to assume.
Yeah.
When
there's an alternative.
Correct.
Yeah.
And I think this is the salient point. Insofar, you mentioned earlier you wanted to kind of bridge the gap between enterprise and Web3, et cetera. But this is kind of the salient point, I think.
Yeah, and that's exactly it. zk has the potential. It is within the grasp of possibilities for it to do these things.
Yes.
And maybe nobody's doing it yet, or maybe some people have some early proof of concepts that don't scale well or whatever. But then it's just a matter of time.
Yes.
And exactly what you said, because the enterprise, sometimes they're reluctant to do things, right? Sometimes businesses, even the Googles of the world, are hesitant to add certain features or enter certain markets because there's so much overhead in a business to maintain compliance, and risk is introduced as soon as you start trying to do that stuff, right? But with this, now not only and then the users, but then the users okay, let's say they did do that, the users are reluctant to use it because they've seen all the headlines for years now of
Equifax.
Yeah, exactly. Yeah, absolutely. Even the credit bureaus themselves, getting hacked, and then they've got everybody, right? So the both sides, both the customer and the business, benefit from this if and when we can realize it. That then the business doesn't have to take on the risk, and the consumer has a tremendous much more faith in the system, and then everybody wins, right?
Telos Enterprise.
Telos Enterprise. Yeah.
Wonderful. Okay, super good. Well, thank you very much. That was outstanding. So let's do this again. We can kind of drill down on some more of this stuff and maybe talk a bit more about Telos Native too, but super cool, and thank you very much.
Absolutely.